So in our first video on learning Python, what we are going to do is we are going to take a look at what are the various keywords that Python as a language provides us as part of its syntax, and then what are the data types that Python as a language provides us with, and then how to go about creating our own custom data type. So let's just get started by launching a terminal. And then what I'll do is, okay, let me close this. What I'll do is I'll navigate to the desktop and then create a directory called Python, right? And as you can see, a directory got created here. Then I'll navigate into that directory and then I'll just create a file. But before we even go there, let's do one thing. Let's just type in Python 3. Well, let's just type in Python 3 and get onto the prompt. Now what you see here is called the Python REPL, which is the read, interpret, execute, and well, load, I think. So REPL stands for that. And I just press Control L and it gets us here. Now what we'll do is we'll just quickly go ahead and write in print hello, comma, world, just as the customary exercise of writing hello world as the first thing any new language that you're learning. Okay, so once we're done with this, what we'll do is we'll try and figure out by asking Python what are the keywords that it supports or what are the keywords of the language. And to do that, what we have to do is we just have to type in help, then open parenthesis, and then within single quotes or double quotes, just write keywords and close the parenthesis and then hit enter. And once you do that, these are all, Python reports back with list of keywords. And this is it. This is what composes or what constitutes of the Python language. There are total 35 keywords, and if you notice, only three of them start with an uppercase, and everything else is in lowercase. So this is something that is easy to remember, and you should remember. One advice here at this point would be to just go ahead and try to memorize all the keywords. As we progress further, you'll figure out that many of the keywords relate to one another, and you can remember them in bunch. For example, if, elif, and else are related, uh, try and except. Where is try? Where is try? Where is try? Okay, okay. Try and accept. Huh. Try and accept and finally are related. So these three keywords are related. For, while, in, is. So you would eventually figure out that there is a relation between a lot of keywords and they occur as a bunch together usually. Okay, so that said, we're going to take a look at what each keyword is as we go through through the playlist, so to speak. But right now, let's just focus on what are the data types that Python provides. Given that we know the keywords, let's just go ahead and try and understand what the various data types that this language provides. And so to do that, what I'm going to do is I'm going to open up a textbook of class 12th CBSE, and the unit 1 in that specifically is a Python review, and that kind of gives a good introduction to Python. And I found that they have also listed here the data types that Python itself provides. And there are, at a high level, 5 types of data that you can have in Python. One is numbers, then you can have sequences, sets, and mapping. And then there is this another special data type called the none. And you can think of none as a representation or a way of representing nothingness. So if a variable or if some value returns back as none, then that just means that it's Python trying to convey to you that that value is nothing, so to speak. It's a void or it's a null or it's a zero, so to speak. Okay, that said, let's just explore. Let's just discuss a little bit about the base data types. So in numbers, It's quite intuitive that you have integers. Integers are like negative and positive numbers together, whole numbers with the negative numbers that becomes integers. And then within integers you have Boolean. So Boolean are data types or data that can only be 0 or 1, true or false, yes or no. That kind of a thing is called a Boolean. Then it also provides us with a floating point, and what floating point means is any number that can be represented with a decimal, decimal points, 1.0, 2.0, 1.1, 2, 3, 4, 5, 6. That kind of stuff is a floating point number. And then there are complex numbers typically used in science and engineering in the research area. So the complex numbers have like a real part and the imaginary part. We'll take a look at that too. Okay, then we talked about none. Let's just quickly go over what sequences are. Well, sequences, as you know, yeah, you might be able to imagine, is just a sequence of some information, some data. And for example, string then is a sequence of characters. Characters are uh, ASCII codes. For example, A, S, D, all of these classified to be a character. And then tuple. So tuple is a collection of numbers, strings, characters, whatever. We'll take a look at the finer details, but imagine it to be like a collection. And list is also a collection. So tuple and lists are pretty much same with one difference that once you decide or once you initialize a tuple, you can never change it. You can never add anything to it. But in case of a list, you can add to it, and we'll take a detailed look at that too. Then sets are like a collection of things that you want to put together. But then the idea of sets is that the collection, every element or every member of that collection would be unique. So in lists and in tuples, for example, you can have an entry like 1, 1, 1, 1, 1, 1, 1, right? 10 ones. But in case of a set, you only have one entry of one element. And then mapping or dictionary. So dictionary is type of data type, which is called mappings. But dictionary then provides you a way to bind a key with a value. So think of it like the real value or real world dictionary, where you have like a word and the meaning is tied to it. The word is the key and the meaning is the value, so to speak. So now let's just go ahead and take a look at the example of each. So let's just get started. Yeah, let me just go ahead and have our famous x, the unknown, and let me give it a value of, let's say, 10. So now, if I were to ask Python to go ahead and print x, it would just print 10, which is fine. Now, what I would do is I would want Python to tell me what is the data type of x. And the way I can do that is I can just say type, open parenthesis, and put x within that, and then hit enter. And it says that it is of the class int. Let's just forget about the keyword class right now. We'll get to that towards the end of the video. But then essentially int is nothing but an integer. So now if I were to set x to, let's say, true, and then ask the same question, like type of x, then it says, hey, it's a boolean. And then if I go ahead and now make x as 1 to 3 and then ask type of x, it says float. And similarly, if let's say I um, huh, well, if I say x equals none, none also happens to be an assignment, then let me ask type, and it says none type. An example of this, yeah, I think I'll make a video which explains more about none, how it can naturally occur, and we can take a look at that. Then, but okay, let's go to sequences. So if I were to have x equals, let's say, Piyush, and then ask Python what it is, it would say it is stir, and stir essentially means that it is a string. Then if I make x equals to open close parenthesis, and within that, if I say 1, 2, 3, then let's ask what is the type of X, and it says a tuple. Now notice that if I use uh, to 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 mark a sequence, in this case a sequence of number, each element has to be demarcated or delimited by a comma, and then they have to be enclosed within a parenthesis, opening and closing parenthesis. And now if I were to make the same thing as a list, then all I have to do is change the parenthesis with a square bracket. An opening and closing square bracket would immediately make uh, X as a list, as you can see, right? And so we're done with sequences, and then let's just go ahead with sets. So now how do I, so X, if I want to declare it to be a set, then I say X is a set, and then I ask it the type, and it says a set. Now what I'll do is I'll try to add into, let me just try and add, let's say 1 to the set, right? And then if we just try to print what X is, uh, X comes out to be a set of 1. Now let me go ahead and add 2 to it. So X then is a set of 1 and 2. And now let me just go ahead and add another 1 into it. And then if we print, X is still 1 and 2. So what this tells you is um, that sets is a collection of unique elements, right? Whereas, if I were to make it a list of all ones, then X is a list of all ones. So remember that sets always contain only unique elements. Cool. So we are done with all the data types, and let's just take a look at dictionary finally. So the way you have a dictionary is that dictionary uh, is denoted with the opening and closing curly brace. And then within that, what you need to do is you can say, for example, Piyush equals, the number 120. And then if you were to print X, it says, hey, there is a string Piyush that is bound with 120. And then if I were to ask Python to tell me the type of X, then it says it's a dictionary. So we're pretty much done with all the data types except complex. So let me go ahead and try and generate a complex number. So if I say 1 plus 2i, well, should have been, I think, I2. Well, not even that. So maybe j, no, not even that. What is it, j? Yep, okay. So the j here is the classic imaginary number, the root of -1. And yeah, this is how you declare a complex number. So if I were to ask then the type of X, then Python immediately tells me that it's a complex number type. Well, with this then we're pretty much through with all the internally provided data types that Python provides us with. And now let's take a look at, what if we wanted a data type of our own. So what I mean by that, let's say we are talking about mm, points in a plane, right? So let me go ahead. Let me go to the desktop, go within this. Uh, Let me then do touchmain.py to create the file, and we see that it is here. Okay, then let me just have some discussion here. So the idea is, let's say I want to be able to save, you know, a three-dimensional point, x, y, and z, representing the coordinates of a point on a three-dimensional coordinate a three-dimensional space. Then how would I go about keeping all of them together? One is that I can do, x equals 1. Well, for example, 1, 2, 3 is the point that I'm interested in. Then y equals 2, and then z equals um, y equals 2 and z equals 3, I could do that, but then what I'm doing is I'm having three separate variables, right? That store, three separate variables, integer variables that store the value 1, 2, and 3 separately. So what I'm wanting to have is like I should be able to do, uh, something which is of the point of the type p equals to say 1, 2, 3, something of that nature, so that all these three values stay stuck together, so to speak. And so one of the ways to do that, to declare your own custom type of data type, the way you do that is you tell Python using the keyword class of how to go about generating that data type. And so let me call in our case point as the data type, and then let me use you know let me just type in the code first, and then let me explain. So then let's just go about doing this. um, okay, and then let's just say self.x equals x, self.y equals y, and self.z equals z. All right, cool. So now what's happening here is when I say class point, then if we go back here somewhere at the top, we see that class is a Python keyword. So class then essentially is telling Python that, hey Python, I want you to create a custom data type for me. And now Python is like, okay, I understand that you want a custom data type, but what is the name of it? And then we mention with a space the name of that data type. So every time I say point, Python would understand that I'm trying to refer to a custom data type. And now in Python, what happens is you kind of start your code block, so to speak, with a colon. So Python understands that, okay, I've seen a colon here, which means that whatever follows must belong to the definition of point, so to speak. But now the problem is, how does Python understand or figure out when to stop correlating the code with the definition of point, so to speak? And for that, we have indentation. So here you see that this code is indented, and then which tells Python that everything at this indentation level belongs to point, the definition of point, so to speak. So here you see another keyword called def, which we should see here, and def essentially is used to declare a function. Now in this case, the underscore underscore init underscore underscore is a function name, and it's a special function name. What I mean by special is that Python internally understands that, or rather, it's a convention, or it's whoever designed Python, they chose underscore underscore init underscore underscore to be the function that essentially does initialization of this object. And we'll take a look at what initialization would mean. So then after this point, if you see that I'm declaring some uh, functional the positional parameters here, which are self, x, y, and z. So self here uh, is again a special reference or special usage within Python, and we'll get to the details of this in the subsequent videos. But for now, just understand that self needs to be passed for any function within a class, right? And so x, y, and z are the coordinates of the point that we are interested in. And then here we are saying, hey, Python, you know, please save these points locally within this class, right? And then other thing that you should see here is that this code block is also indented, which means that all of line 3 through 5 belong to the function in it. And that's about it. And then after this point, so if I were to go back to the Python 3 REPL and then copy all of this. Let me just paste it here and hit enter. Then if I were to say X is now of the type point, you know, now let me give it 1, 2, 3. And then if I ask, okay, what is the type of X? Then it says, hey, it's of the type main dot point. Let's forget about main here at this point. It's just this is just conveying to us that point is a custom data type that was defined up here. That's about it. And then we'll see what else can be done with Python in terms of how to go about structuring the programs and how to think about coding in general, and also we'll decipher all of these cryptic looking things. But right now I just wanted to show you how one can go about creating their own custom data type, and what are the internal data type that Python provides us with, and what are the keywords of the language. And then with this, I'll see you in the next video. Bye bye.